Let's start by taking a look at the notation for inverse trigonometric functions. Notice this notation that we have on the page. It says sine, and it looks like superscript -1 of a. Well, we actually read this as inverse sine of a. And so that's the way we read it. Never, ever, ever, ever think of the -1 as an exponent in these situations. It might look like an exponent, and thus you might think it's 1 over sine, but this is certainly not true. Right? When we actually see 1 over sine of z, and I change the letter, that's actually the cosecant of z, and you may remember that. We'll talk about that later on in these chapters. But 1 over sine z is cosecant. It is not the same as inverse sine. So inverse sine means we're thinking backwards. Cosine with the superscript -1 of a, we read as the inverse cosine of a. So again, it's not 1 over the cosine. Please, please, please don't think of it that way. And inverse tangent of a looks like the tan with the superscript -1. And again, we read this inverse tan of a. We're thinking backwards. We're not thinking reciprocals. So let's talk a little bit about the behavior of these functions. And let's start with the behavior of inverse cosine. Now, notice if I take a look at the graph of cosine, which I have on the screen right here, that cosine itself does not pass the horizontal line test. And from what we said earlier on in the course, that means that the entire cosine function is not invertible. So you might say, well, then how can I talk about inverse cosine? Well, what happens is in order to discuss the concept of the inverses of trig functions, we're actually going to make the game work for us. And the way we do that is we restrict our view of cosine to an interval where it does pass the horizontal line test, where it is in fact 1 to 1. And then what we also do is make sure we choose a portion of the graph that produces the largest possible set of range values. And so in this case, for cosine, we're going to use everything from 0 to 180 degrees, including 0 and including 180 degrees. And I actually shaded that with the yellow on my graph. And so you'll notice that that's a piece that passes the horizontal line test, and it gives me all of the cosine values, because remember, cosine's smallest value is -1, and its largest value is 1. And so this range works out very nicely for me. So kind of saying what we've said here, moving forward. So for our restricted region, the input or domain of the cosine of x is an angle, then, in the range in the interval between 0 and 180 degrees inclusive. And the output of the regular cosine function is going to give us a value between -1 and 1. So the x's in regular cosine up to before this section, cosine is, we're going to be using 0 to 180, and then the output values are -1 to 1. If I went in my calculator and I graphed the inverse cosine, or I carefully did the reflect over the line y equals x, or I interchanged the values that correspond to these x's and y's, I would get a graph that looks something like this. Notice, remember when we do inverses, the range becomes the domain. So notice that this graph is only showing us from -1 to 1 on the x-axis. And what it would be showing us if I had put a scale is on the y-axis, values from 0 to 180 degrees. So now, if I talk about the inverse cosine, again, I interchange my domain and range. And so the input or domain of the inverse cosine is going to be a number between -1 and 1. So notice the input on inverse cosine is not an angle. What happens is it's the values we could get for cosine, and the output or the range ends up being the angle, and the output on inverse cosine will be between 0 and 180 degrees. So the inverse cosine also has another name. You'll sometimes hear it referred to as the arc cosine. Notice, by the way, that arc cosine has 2 C's in it. Not that that's critical, but it is actually the word arc with the cos on the end of it. So that notation is the same as that inverse cosine notation. And in some ways, I actually like this notation better, although your book doesn't really use it. You're less apt to do the 1 over thing that we were worried about. So just kind of to clarify one more time, if y equals the cosine of t, then to write the inverse notation, we would say t equals the inverse cosine of y. If you remember back when we did the solve for the other variable, that's really what I've done here. And t will be the inverse cosine of y, provided that t is between 0 and 180 degrees. And also remember the y would have to be between -1 and 1. So be very, very clear and sit and kind of chew on this before you move forward.